What is displacement current and why is it confusing? Imagine you're watching a river flow. The water moves, creating currents that carry energy. Now picture a situation where no water moves, but the energy still flows. That's kind of what displacement current is all about. It's a concept in electromagnetism that helps us understand how changing electric fields can produce magnetic effects, even when no actual charge is moving through space. Displacement current was introduced by James Clerk Maxwell to fill a gap in our understanding of electric and magnetic fields. Think about a capacitor, where two metal plates are separated by an insulator. When you connect it to an AC power source, the electric field between the plates changes over time. But no charges actually jump across the insulator. Still, the magnetic field around the capacitor behaves as if there is a current flowing. That's where displacement current comes in. It acts like a real current, even though it's not made of moving charges. Mathematically, displacement current is described as the rate at which the electric displacement field changes with time. The electric displacement field, often written as D, depends on the electric field and the permittivity of the medium. When the electric field changes rapidly, the displacement current increases. This is important because it keeps Maxwell's equations consistent. Without including displacement current, the equations wouldn't work in situations like changing electric fields or in a vacuum. In Maxwell's corrected version of Ampere's law, the magnetic field depends not only on conduction current but also on the displacement current. This addition explains how electromagnetic waves can travel through space. It also clarifies how signals move in circuits with capacitors and in antennas. The confusing part is that displacement current isn't a flow of actual charges. It's a mathematical term that represents the changing electric field. This can seem strange because we usually think of current as moving electrons or ions. But in this case, it's the changing electric field that creates a magnetic field, acting just like a current. In practical electrical engineering, understanding displacement current helps us design better high-frequency circuits, antennas, and communication systems. It's essential for explaining how electromagnetic waves propagate and how devices work when electric fields change quickly. So, even though it might seem abstract, displacement current is a key piece of the puzzle in understanding how electricity and magnetism work together in our modern world.